Hello everybody. So today I'm going to be covering how to do regressions in Excel and getting regression statistics. So I know some of you already know how to do this and we've seen it in class a few times, but this video will kind of be a guide on how to do it. A couple other things I'm going to do in this video is mention a couple common mistakes I saw in the project draft, which will need to be fixed for the final project. I'm going to show you the final project document and discuss a little bit about that for now, but discuss that more in future class periods or videos, depending on what happens with campus policy related to the coronavirus. So I'm going to start by, here I'm just at the home of the Canvas page. I will start by just scrolling down and let's take a look at the project draft. So two of the main mistakes I kind of saw in the project draft. The most important one was that the very last sentence in the project draft says, make sure to interpret the slope of the equation of the line that you displayed in your scatter plot. So a lot of people did a good job of this, but the biggest mistake I saw is some people just said the line is going up or the trend is going down, but you need to do a direct interpretation using the estimated slope. The other big mistake I saw and I would have mentioned both of these in the comments for your project draft if you had made either of these, is that we want everything, including charts, into a single professional looking document for the final project. So you really want this thing to be a single professional looking document at the end is the goal. Now let's take a look at the final project. So if I go over to assignments, here's the project. Here's the document for that. So let's take a closer look at that. So this just talks about when you submit it, there's going to be a maximum of 10 pages because I don't want it to be super long. I want it to be concise and professional. But the main thing we want to focus on today are the minimum you must do when revising your project from the project draft you submitted to the final draft include the following. So number one is fixing anything that I mentioned in the comments that I made. So I will be comparing your draft to your final to make sure that you've done that. That's going to be number one. The second thing we're going to discuss in this video is discussing the statistical significance of slope estimates and other regression statistics for all models presented. So for example, that's going to be comparing R-squared values across models for a second. I'll get more specific about what that means in the future, but we'll talk about the three big components you will need to take care of step 2 today through an example. So our example today is going to be based on a file that's available to you in Canvas. So if you could click on Files here, and then go down, and we're going to use the GDP inflation regression data that we've actually taken a look at in the past too. And if I click on these three dots, I can download that. In Chrome, it shows up right here. It might show up somewhere else if you're in a different browser. But just as a reminder, this GDP inflation regression data spreadsheet has all three data types that have been discussed. So we have time series with Australia GDP growth rate and inflation rate. And so this is time series data because this is just in Australia over the years. We also have cross-sectional data. So we have GDP growth rate in a bunch of different countries in a single year in 2015, and then the inflation rate. And we also have panel data of the same thing. So here we have year and country, and then those repeat. So we have variation across space and across time in this data set, which is a panel data set. So all of this, regardless of which of these three types of data sets you have, the steps we go through today will be the same. We're going to be asking the research question, how does a GDP growth rate affect inflation? So the theory kind of is that, well, if the economy heats up, then prices will increase faster, so we might expect a positive relationship. On the other hand, in some countries that are maybe less developed, we might see really high inflation rates and low GDP growth rates for institutional reasons, and we've discussed that before in class. So let's start out by notice how my data is organized. This is important. I have a pairing variable, and then I have my independent variable and my dependent variable. When you have your data in that order, we could make one of our scatter plots by highlighting the independent variable on the left, the dependent variable on the right, insert, scatter plot. And then, as you know, we probably want to change the title on stuff on this today to make it more professional looking. For now, I am just going to do this kind of quickly because our main focus is statistical significance today, but this is just kind of a review of what we've done with these regression lines before. We like to put the equation on the chart. Let's put it up here so we can see it. Let's make it bigger so we can see it better. And then one thing I suggested that is a good idea is instead of using just arbitrary X and Y, let's use the actual names of our variables because then it'll be easier for the reader to understand. So let's just write inflation rate where the Y was, and we can delete the X and write growth rate. And so now that's a lot easier for our reader to interpret this equation because now it's just not about an arbitrary X and Y, it's about our project. It's about how the growth rate affects the inflation rate. So getting to the big mistake that a lot of people made, and it wasn't necessarily a mistake, I could just say, based on this data, there is a negative relationship between growth and inflation. So inflation's high, growth is low. Inflation is low, or sorry, growth is low, inflation is high. But what I really want, because we've spent a lot of time working on getting this specific estimate, a direct slope interpretation would be a statement like, when growth rate increases by 1, inflation rate decreases by 0.3047. And you'd want to use your units and everything, but that is the most basic and specific slope interpretation. So a lot of people were missing that specificity by actually using the number that you estimate. So make sure to fix that issue if you happen to fall into that category. But today, let's figure out this equation and graph does not tell us anything about the statistical significance or the fit of the model. As you've seen, we could put an R-squared on this graph. That would tell us a little bit of information about those issues. But what we really want to do is use the data analysis Toolpak. So if we go to the data tab, we have this data analysis. If you don't have that on the computer you're using to follow along or to work on your project, you can go in the files. I have Excel tips and tricks right here. That document goes over how to get the data analysis Toolpak, which we've also gone over in class a lot, so that shouldn't be too big of a problem. But if you forgot how to get this, whether on a Mac or on a Windows machine, that document will walk you through it. So now, let's use that to do a regression. So if I click on Data Analysis Toolpak, right there I have a menu item called Regression. I'm going to push OK. Sometimes that will load whatever you did last, so that's not going to be the right numbers in this case. Let's delete that. This says input Y range. Well, my Y is my dependent variable, which is inflation in this case. So I'll click on inflation rate, Shift Command down arrow. I will go click on GDP growth rate, which is my X range or my independent variable. So I click on GDP growth rate, Shift Command down arrow. Notice I have labels clicked here. That won't be automatically clicked necessarily, so you need to check that. I have that clicked because I included my labels, which I strongly encourage you to do, because then they'll show up when we look at our results. Let's go ahead and put this on the same worksheet that we have our data in. So it says output range. E2 is fine, but what I'll do if this starts blank is click output range, and then I'll go click on E2. I kind of like to put it just to the right of my data. And then we're ready to go, so let's push OK. And there are regression results. The first thing I want you to notice is look at our slope estimate right here. So there's kind of three important numbers I want you to be looking at right when you get your regression results. The three most important numbers you're going to look at are, first of all, your point estimate of the slope, which is right here. So I like to just make myself a little menu and copy these down. So I'm going to write slope, and then I'm just going to copy this number, Command C, Command V, and now it's very clear to me that's my slope right there. Notice that that matches the slope we got in our scatter plot. It should. If it doesn't, something's gone wrong. This one's rounded. This one is not rounded as much. But if those numbers do not match, you've highlighted data incorrectly or something went wrong along the process. So that's kind of a good check to make sure those match. The second thing I want to know is my slope statistically significant? So I have my slope right here. Let's go ahead and take our p-value and copy that and put it right here. And now I know that my slope for this particular set of data is very statistically significant. 0.00087 or 88. That is less than 1%. Really, it's less than 0.1%. So significant at all of the thresholds, 1%, 5%, and 10%, and also just significant in general. So let's do a direct interpretation of the p-value now. If I get this p-value, I will say something like my slope is negative 0.3047. I'll interpret that slope, and then I'll always say this is a very statistically significant slope with a p-value of 0.08%, 0.088%, meaning that there is only a 0.088% probability that I would observe this slope in a world where the null hypothesis is true. The null hypothesis is that there is not a relationship between growth and inflation. We can now take this p-value to mean that's probably not true. There probably is a relationship between growth and inflation, because there's a very small probability I would have observed this slope estimate if there was not a linear relationship between GDP and inflation. Now, the third number that we've gone over in class, the coefficient of determination, or R-square, is also presented up here. So let's copy that and bring it down. And by doing this, I don't have to go look around in all of these different numbers to extract. I can make myself a nice little menu of really the important stuff I care about. So slope, is it statistically significant? And now, how much of my data is explained by my regression? More specifically, how much of the variation in inflation rate can be explained by variation in GDP growth rate across countries? This can be interpreted as a percentage. So that's 4.7%. So in a sentence, 4.7% of the variation in inflation can be explained by variation in GDP growth rate. So that's how we interpret the R-squared. Again, 4.7% of the variation in inflation can be explained by variation in GDP growth. So the three important numbers again, we have slope, p-value, and R-squared. This tells us our point estimate of the relationship. This tells us if that point estimate is statistically significant. This tells us how much of our variation in our dependent variable can be explained by variation in our independent variable. So this should help you do this for your project. I encourage you to do this in this spreadsheet because that data is available to you, and then also practice it with your project. All of the information I'm talking about here and the interpretation, especially of these three numbers, will be important both for your project and for the test. Don't hesitate to let me know if you have any questions. Right? And have a good one.